So hi guys, today we'll be talking about blending and pasting of operations of images using OpenCV. These are the contents we'll be discussing. First, I'll be giving you a basic introduction of what these operations are. Then we'll go into the details of these operations. Then I'll tell you the basic difference between blending and pasting, and then we'll see the use cases of these operations. So let's dive into the theory first. So what are blending and pasting operations? Basically, blending is like combining two images, and pasting is like fixing one image on top of the other. And these can usually be done with other graphic designing tools like Illustrator, Photoshop, etc. But when you want to automate it for a large number of for bulk data, then you can use OpenCV. And these are commonly referred to as basic arithmetic operations because they use simple matrix addition and matrix multiplication processes. So today we'll be using these two images as our reference. This will be the main image and this will be our watermark. Okay, now let's see how pasting is done. Like I said, pasting is just putting one image on top of the other without making any other changes. So these are the steps we need to follow. Alright, so I'll explain the code. Here we'll be loading both the images, then we'll be seeing the shape of each of them, size, etc. Then we resize the watermark into a desired one. Once that's done, we'll select a region of interest where we pick the position where we want the watermark to be fixed on the main image. So we'll give the starting coordinates of the rectangle. Then we'll add the width and the height to the starting coordinates to get the end point of the rectangle. Once we specify that, we'll simply replace the pixel values of the original image, BG, with those of the watermark. So the pixel values of the watermark are put in place of the pixel values of the background image. That is simple. So that's pasting, and then we'll show the result. Now we'll move on to blending. Blending, like I said, it's combining two images together. To do this, we use the cv2.addWeighted function, which we learned earlier. So this function takes four main parameters. Two are obviously the main image and the watermark images. So those two will be alternate, like 1 and 3. The first parameter and the third parameter will be the main image and the watermark image. The second parameter and the fourth parameter are known as alpha and beta values. So the value of alpha determines the weight or importance of the first image that is given in the final output, and beta determines the weight or the importance given to the second image in the final output. I will explain how that works. So suppose here, for example, we take alpha as 0.5 and beta as 0.5. So when this is taken, both will have equal weightage. Both the first image and the second image will have equal weightage in the final output. But when we take alpha as 0.8 and beta as 0.2, then the first image will have a little more importance in the final image than the second image. So the second image will be very light, while the first image will be more prominent. So here I've mentioned images when both the background image and the watermark are of same size. It's easy to blend them. There's not much process we need to follow. But when we're blending images of different sizes, there are three major steps that we need to follow. First, we'll paste the image. First, we'll process the images, and then we'll paste them. So we'll see how that's done. So first, we'll see how blending of images of the same size is done. These are the steps we need to follow, right? So first, we'll be loading the image here. Then we'll be displaying both the images to understand. Then we'll be resizing both the images to the same size. And then we'll be using the addWeighted function here. Here I have used three different cases. First case, alpha is 0.5 and beta is 0.5. Second case, alpha is 0.8 and beta is 0.2. And in the third case, both alpha and beta are 1. We will see what the difference between all these cases is in the next, when I show you the practical implementation of this code. So like I said, the first and the third parameters will be the image and the watermark, and this is alpha, well this is beta, this is gamma. It doesn't have much importance. So now we'll move on to blending images of different sizes. Like I said, there are three major steps for this, but I have elaborated the steps and given them here. So we'll look into the code. First we'll load the images as usual, then we'll display them, then we'll resize the watermark to our desired size. Then, like we did for pasting, we will define the region of interest, that is ROI. So we'll define the starting point, then we will define the entire rectangle, how much from x, starting x to ending x, from starting y to ending y. So we'll describe the ROI here. Then we'll show the ROI. We'll display which part is taken as the region of interest. Then we'll convert the watermark into a grayscaled one. Then we'll mask it using cv2.threshold. Then we will use bitwise OR functions, these are all functions which we have learned earlier. So we'll use the bitwise OR function here with the region of interest. So here we'll grayscale the watermark and we'll mask the watermark. Once that's done, we'll use bitwise OR on the region of interest and the mask. Then we'll invert the mask to get back the original image. Since we converted it to grayscale, we need to get back the original colors of the image. So we'll be doing that, and then we'll use the bitwise AND on the inverted mask. Once that's done, we'll be showing how the region of interest looks like with the watermark on it. So for that we'll use cv2.add. Once that's done, we will simply replace the pixels of these. We'll simply replace the pixel values of the specified ROI in the background image with the pixels we got over here using this pixels. So that's what we'll be doing here. So we'll assign the final ROI here which we got to this variable, and we'll be replacing the pixels of the background image of the ROI of the background image with the variable we mentioned. So that will give you the final result. So blending versus pasting. So pasting is just simply taking one image and putting it directly on top of the background image. So this is what we've done here. So this is what pasting looks like. But blending is like morphing the image a little so that we can get something like a watermark or other stuff. Then we'll be going applications where these are used are graphic designing on a large scale. These are all when we need the images to be processed in a large scale. Like suppose there's a data set of say thousands and thousands of images, then you can't use graphic designing tools like Illustrator and Photoshop to merge each image into the desired form. So we'll be using OpenCV processes to be able to do this. Now I will show you the implementation of this. So pasting images. So it gives us the height, width, and the color channel. So usually colored images have 3 channels, so that's what it shows here. Now pasting operation is done, and this is the original image. This is the original watermark, and this is the resized watermark. So once that's done, so this is the pasting result final result. This is what it looks like. We'll move on to blending images of the same size. So like before, again, we will run this. This is the original image and this is the original watermark. Now we'll resize both the watermark and the image to get both of the same size. So as you can see, both of these are of the same size here. Once that's done, we move on to blending. So like I said, I have included three cases here where alpha and beta is 0.5, where alpha is 0.8 and 0.2, and this is alpha and beta at 1. So we'll understand the difference. So this is what it looks like when both are at 0.5. So the intensity of both images will be half the original intensity. Now here, more weightage is given to the main background image since alpha is 0.8. So the intensity of the first image will be more than the intensity of the second image, as you can see here. Now when both are given an intensity of 1 each, so this is what it looks like. Now we'll move on to images of different sizes. So this is the original image like before, and this is the original watermark. This will be your resized watermark. Yeah. So like I've mentioned, we'll be specifying the ROI. So this is the output of the ROI. So this is taken as the output. This point is the coordinates of the starting point that we've given. And this, when you add the height and width of the ROI to this starting point, you will get this. So that's how we define the ROI. Then we take the resized watermark and we convert it to grayscale. Then we mask it. Then we'll display the result while after pasting this mask on the ROI. Now we'll invert this mask and get back the original colors converted to 3-colored image, and we'll paste this 3-colored image on this ROI. So that is this. This is the result of the pasting. So once that's done, we will be able to get the final image. So that's the final image. So the pixel values are changed accordingly and we get the final result. So that's it guys. Thank you.